Come on, let's move. Science sucks.
In a process known as primordial nucleosynthesis. After this process, the universe contained about 75% of hydrogen, 25% of helium, and a tiny, almost negligible amount of all the other elements.
Crazy one.
Can you sing this?
Can I help you?
I've lost my group. Did you see which way they went?
Don't worry, you'll find them. What's your name?
Alma?
Beautiful name. Do you like it here?
Yeah, but I don't really understand anything.
Well, maybe if you could see it closer. Come with me.
Where are you taking me?
I've got stuff to do with Lucy, and they'll be waiting for me at home. Oh, that's so cool. There are so many stars.
This is our galaxy, the Milky Way. It contains approximately 100 billion stars. The European Space Agency's satellite Gaia has identified almost 2 billion of them and is discovering thousands of new ones every day.
Wow, it's like a map of the galaxy. And where's my home?
Well, the sun is there, and we're a bit suburban in the Orion arm. Do you want to see it closer?
Sure, but we'll be going back to Earth later, right?
Put this on. The light is quite bright here.
Wow, it's huge.
The sun's diameter is over 100 times the Earth's. But it's a totally average star as far as the size and mass are concerned. It's a small star, but it's our star.
It doesn't look solid like Earth. It looks like it's boiling.
Well spotted. The sun is almost entirely made of gas, hydrogen and helium, the two lightest chemical elements, which have been around since the universe was born. Heavier atoms like carbon, oxygen, and iron are produced inside stars, elements that also make up your body.
It's really hot. Maybe it's not that big as a star, but it really burns.
What happens inside the sun's core are nuclear fusion reactions, transforming hydrogen and helium and releasing huge quantities of energy. Have you ever heard of Einstein's equation, binding mass and energy?
Actually, I haven't. Yeah, right. A schoolmate has a shirt with that formula. But what does it mean?
Energy equals mass times the speed of light squared. Inside stars, for example, mass transforms into energy.
Is that why it's so bright?
Indeed, every second approximately 600 million tons of hydrogen are transformed into 596 million tons of helium directly. It doesn't add up, right? That's because the missing 4 million tons are directly converted into energy, into the light and heat which make life possible on Earth.
But does that mean the sun's being consumed like a candle, and one day we'll be left in the dark?
That's right, Alma, but don't worry. It will be stable for billions of years to come. Then, when the hydrogen in its core runs out, it will expand massively, becoming a red giant. And finally, in approximately 8 billion years, all possible nuclear fusion processes will have been exhausted, and it will become a white dwarf. It will contract and become more or less as big as Earth, the peaceful relic of a star.
So, it'll shrink and become 100 times smaller than it is now?
Exactly. But in the universe, there are much bigger stars than the Sun, which have transformed into far smaller things. Do you know what a supernova is?
It rings a bell, but I couldn't say.
Do you see this star? We call it a blue giant. It's many, many times bigger than the Sun, and it has 10 times its mass. Stars that big consume fuel for nuclear fusion much faster. And when they run out, they explode in some of the universe's biggest explosions. Supernovae.
That sounds kinda scary.
On average, there's one supernova explosion per century within our galaxy. Since none have been detected since 1604, you'll probably see one in your lifetime. But don't worry, it's very unlikely that it will happen close to us. And it will not cause any damage to Earth if it is at a safety distance of a few hundred light years.
If they're so rare, how do we get to see them?
Thanks to modern telescopes, such as the European Southern Observatory, we can see supernovae in faraway galaxies too, and we see many hundreds of them every year. The last supernova visible to the naked eye appeared in 1987. Look at how bright it was. This other supernova exploded in 1054, and that's the nebula we can see today.
It's wonderful. It really looks like the leftovers of a huge explosion. But why won't the sun become a supernova and some other stars will? What's the difference?
Larger stars have a much higher gravity than the sun. When the fuel starts to run out, nuclear fusion processes become unable to compensate for gravity. Then, the inner core of these stars suddenly collapses and the star explodes. Supernovae are so luminous that for short periods they may emit more radiation than an entire galaxy.
And what's left of the star after the explosion?
Well, that's where things get really amazing. The star's surface layers are propelled into deep space and form nebulae, which I personally find very beautiful. The energy of the explosion is so high that elements heavier than iron can form. Gold, for instance, can be formed inside a supernovae.
Wow, but where does it end up?
It depends, sometimes inside a pocket. But in a supernova explosion, only the outer layers are ejected into the cosmos. The star's core is compressed into what we call a neutron star or a pulsar, or, in the most extreme cases, into a black hole. Pulsars are truly special stars. I'm so fascinated by them. I've been studying them all my life. Just imagine. There's one. Can you see that small sphere?
Yes! It looks like a very bright, tiny star.
It's tiny indeed for a star. Its diameter is just about 20 kilometers, but it has more mass than the sun.
How is that possible?
It's the force of gravity, billions of times greater than that on Earth, compressing the star's matter to a density similar to that found in an atom's nucleus. It's so dense that a teacup's worth of neutron star would weigh more or less as much as Mount Everest.
Wow. It's so small and far away. It must be really hard to see, right?
Yes. Our vision is limited. To see it properly, we need devices sensitive to radio, X, and gamma radiation. This is why the European Space Agency builds huge X-ray satellites like the XMN Newton or the future Athena Observatory. Have a look through this screen sensitive to X radiation.
Now I can see a very intense light flashing on and off.
And if you translate the radio flashing into sound, you can listen to them too. Here. They're called pulsars because they're just like a beacon spinning at perfectly regular intervals so that they appear like a pulse. This very intense beam of radiation is produced by the pulsar's magnetic fields, billions of times more intense than any we can produce on Earth. Some special pulsars, called magnetars, have such powerful magnetic fields that if they were one at the same distance as the moon, no electronic device could function on Earth.
It's good that they're so far away from Earth. Why is it spinning so fast?
Have you ever seen a skater training?
Sure. A friend of mine is a skater. I've seen her.
And what does she do when she wants to do a quick pirouette? Let me tell you. She pulls her arms in. Because she knows the more compressed her mass is, the faster she will spin. That's why pulsars spin so fast, up to hundreds of times per second if they're young, with perfect regularity.
Like a beacon spinning on itself really fast.
At first, these pulsating signals seemed inexplicable. This phenomenon was first observed in 1967. Just a few years ago, if you think about it. Although it might seem a long time ago to you. A young 24-year-old woman scientist pointed a radio telescope to the sky and picked up some mysterious signals. They were so perfectly regular, people even thought that they had been sent by aliens. It seemed to be some mysterious language. But it was the first pulsar ever spotted in history.
And it was discovered by a 24-year-old woman.
Yes? Does that surprise you?
No, it's just that I've never heard about any famous women scientists so far. But what use is it to have discovered pulsars? I mean, what do we do with it, apart from knowing it?
Well, for instance, by emitting such regular signals, pulsars can be used as a sort of cosmic GPS navigation device. They are the most precise clocks in the universe, and thanks to this characteristic, with some sophisticated device, we can determine our location very precisely and orient ourselves in the galaxy.
Does this mean that we have some kind of space coordinates?
Exactly. Many years ago, the Voyager probe was launched into space and is currently the farthest man-made object from Earth. It has already left the solar system. Do you know what we put on the Voyager to explain to a hypothetical alien civilization how to find us? A gold plaque showing Earth's position with respect to 14 pulsars.
Cool. A kind of space message in a bottle. You know, I thought the cosmos was much more boring, but there's amazing stuff going on out there.
Indeed. And that's why I'm so passionate about it. Come with me. I'll show you some very special pulsars. Here we are. Some pulsars have a companion, and we call them binary pulsars. See how they dance around each other as they lose energy, generating waves that can deform space-time, gravitational waves. Now look, those neutron stars are about to merge into a single object. If their total mass exceeds 3 times that of the Sun, they will become a black hole, the most extreme object in the universe, so dense that even light cannot escape its gravity. Isn't that breathtaking?
They've become a black hole. Amazing. I've heard about them a lot. Black holes can grow by gobbling up matter, right?
Exactly. A black hole can keep on growing for billions of years. There are black holes with a mass millions of times that of the Sun. They are the heaviest objects in the universe. Just imagine. Every galaxy contains a supermassive black hole at its center. The Milky Way has its own as well. It's called Sagittarius A star. Let's go and have a look.
It looks like a hungry monster.
Yes, it's quite voracious. It swallows gas and stars and continues to grow. Black holes are very difficult to see. We only very recently managed to capture an image of the black hole at the center of M87, a galaxy close to the Milky Way.
Crikey, you know loads of things about the universe.
It might appear so, but don't be fooled. You have no idea of how many things are still to be discovered about the universe. Just think that 85% of the matter in the universe is invisible, and we have no idea what it's made of. We call it dark matter.
That's kind of a scary name.
Look, there are approximately 100 billion galaxies in the universe, each of them with approximately 100 billion stars, and dark matter permeates everything. Maybe one day you will be the one discovering what dark matter is made of.
I'd never have thought so, but I'm beginning to think I might like to.
Great! So we can meet again. Maybe next time you'll explain a few things to me.
Alma, where were you? I've been looking for you everywhere. Hurry up, we're leaving.
Lucy, you'll never guess where I've been.
Yeah, with your head in the clouds, as usual.
Alma, did you like the museum?
Oh, amazing.